Hey guys, these are parent functions. And this is my parent, my mom. First graph is linear. To begin with, the input is y equals x. The geometric figure is a line. The domain is all real numbers along with the range. Also, y equals x, which is, the parent function for a linear graph. This is also the line of symmetry for an inverse. So y equals x squared is the parent function for a quadratic formula. The input's going to be y equals x squared. It's going to form what's known as a parabola. The domain is all real numbers. The range is all non-negative real numbers. It's pretty much all I have for quadratic. For a exponential, the parent graph, there isn't really a parent graph. An exponential graph is going to be in the form y equals b to the x. Obviously b is not a number, so what we used for this case is we couldn't use 1 because 1 would just get you, it would just be a straight line. 1 to the x is just a straight line, straight horizontal line. So we just made it y equals 2 to the x. So pretty much it's gonna, it's gonna form an asymptote that's gonna be, it's never gonna touch the x-axis, but it goes on forever. The domain is all real numbers, and the range is all positive real numbers. We're now going to talk about a logarithmic function, and the input for that is y equals log x. That is the parent function. The domain is all positive real numbers, and the range is all real numbers. Okay, so the parent function for the square root of x is y equals square root of x. It's going to form a kind of a parabola, except, the domain is going to be all non-negative real numbers. So it can be 0 up to, positive whatever. And the range is going to be all, as well, not all non-negative real numbers. It's kind of going to look like an x squared function, but on the x-axis. Except it's not going to have the bottom part because you can't have a square root of a negative number. We're now going to move on to absolute value. The input for this one is y equals x, except the x's are going to be in between, or the x is going to be in between the lines, telling you that it's absolute. It's going to form kind of a V shape instead of a parabola where there is a slight curve towards a vertex. The domain for this one is all real numbers, and the range is all non-negative real numbers because it's never going to go below the x-axis because this is a parent function. And that's really all for the absolute value. Moving on to the reciprocal of x, which is y equals 1 over x. It's gonna look very strange. It's gonna have a positive and a negative side. Now the positive is going to be on the first quadrant, while the negative is going to be on the third quadrant. So, and what it kind of looks like, it kind of looks like a, I don't really know how to explain it, but pretty much it has two asymptotes, which is the x and y axes. So the domain, it's going to be pretty much infinite. It's going to go on forever, but never touch, the axes, as well as the range, Okay, so now I'm going to go over inverses. Pretty much what an inverse is it's just where the x and y are flipped. Now, for a definition, it's a function that undoes another function.
for a linear equation such as y equals x, if it's y equals x, it's going to be y equals x again, because the x and y values flipped is still x equals x, y equals x, and that's only for the parent function of the linear. If you're talking about quadratic, you're gonna end up getting is a parabola that has been flipped over that y equals x axis. If you have a parabola that's flipped on the over on its side per se, it's gonna you may only see the top part, the part that is positive, and that's because you can have negative square root. So what you would have for that instance is y equals positive or negative square root of x. Now this is only for quadratic. Now for the inverse of a absolute value, it's actually going to be pretty interesting. F of x is the absolute value of x, but the inverse of this is actually positive or negative x. So it ends up looking like a v at first, and the inverse is actually more of an x, where you see both lines. So it's kind of interesting how the inverse overlaps it. Exponential is pretty much the flip of logarithmic. So those two things they're pretty similar. They both have asymptotes, where for the exponential it's going to be x-axis, and for logarithmic it's going to be the y-axis. Okay, so moving on to reciprocal of x. The parent function, it's going to be y equals 1 over x. Now, what's interesting is that the inverse of this actually is the same thing as its parent function. I mean, it's symmetrical when it started, and when you flip it across the y-axis, or the y equals x axis, yeah, it just happens to be the same thing. So that's pretty interesting. So the last thing I'm going to talk about is going to be the inverse of y equals the square root of x. It doesn't actually make a parabola. Now it only makes like the 1/2 part of it, which is kind of strange, but that's what it is. I mean, there's no Wolfram Alpha is telling me there's no result found in terms of standard mathematical functions. But what it did show is the half of the y equals x graph, or I'm sorry, y equals x squared graph, that is in the first quadrant. And I think that's pretty much follows the basic rule. And the most important rule of inverse is the y equals x is the line of symmetry, or where the inverse will be found. So hope you enjoyed the video. Thanks.